Okay, so we are going to be finding the exact values for any trig function. And there are 4 steps. You don't have to go through all 4 of these steps, but this is just a way to do it at first to get you acclimated to finding the exact values of any trig function. All right, so the first thing you want to do is whatever angle they give you, you want to determine what quadrant the angle lies in. So if the angle is not between 0 and 360, then you will find the coterminal angle, subtract or add 360 until you get it in between 0 and 360, and then that tells you what quadrant we're in. Then you'll find the reference angle, and I'll talk about that in just a minute. Then we use that reference angle to find the exact value. And then the last thing we'll do is determine whether the exact value is positive or negative. Okay, so the reference angle by definition is an acute angle, so it's less than 90 degrees, and it's formed by the x-axis and the terminal side of theta. So that's going to be very important to remember. So if you're in quadrant 1, for example, let me draw a little picture here. If you're in quadrant 1, well, all the angles in quadrant 1, so this is quadrant 1, all the angles in quadrant 1 are positive. So if the angle's in positive in quadrant 1, the reference angle is itself. Okay, so that would just be, let me erase that, theta. Okay, going on to quadrant 2, remember it has to be formed by the x-axis, so you're forming it from 180, right? So to find that reference angle, you would subtract theta from 180. All right, going on to quadrant 3, we're still going from the x-axis. It's always going from the x-axis. That's what you've got to remember. So instead of subtracting from 180, we actually subtract 180 from theta. That's going to give us our reference angle in the 3rd quadrant. And in the 4th quadrant, we're still going from the x-axis, but in this case it would be 360. So our reference angle would be 360 minus theta. Okay, and then the last step is to determine whether the exact value is positive or negative. And this you can just make sense out of it by what you know from the rectangular coordinate system and x and y. All right, remember that we said that x was cosine of theta and y is sine of theta. All right, and if you think about x and y in the 1st quadrant, x would be positive because we're going to the right, and y would be positive, so we're going up. That means that sine is positive, cosine is positive, which means tangent is positive, which means all the reciprocals are positive. So all the trig functions are positive in the 1st quadrant. All right, using the same logic, if we went to the 2nd quadrant, we would go to the left, which means cosine is negative, but we go up, so sine is positive. So sine would be positive in the 2nd quadrant, as well as its reciprocal, which is cosecant. And the other 4 trig functions would be negative, because remember that we already said cosine is negative, but tangent is sine over cosine, so that would be a positive over a negative, which makes a negative. All right, so the only 2 positive functions are sine and cosecant in the 2nd quadrant. The 3rd quadrant, that would be negative, negative, which would make sine negative, cosine negative, but it would make tangent, because tangent is sine over cosine, negative over negative. It would make tangent positive, and its reciprocal positive. And then in the last quadrant, we go to the right and down. That means we're going positive and then negative. So cosine is positive, which would make secant positive, and everything else negative. All right, so the way I remember this is I remember the big 3. So I remember all seniors take calculus, and that just is going counterclockwise to remember what trig functions are positive and negative in each quadrant. All right, So let's do some examples. Our first example says to find the reference angle. All right, so let's just draw a picture here. Remember, we're going from the x-axis. Everything's coming from the x-axis. So 155 degrees, what quadrant is that in? Well, here's 180, so we're in quadrant 2, right? Quadrant 2. So I'm going from the x-axis. Actually, let me draw a picture. So let's just say, here's my initial side, and I'm going over here, and my angle was right there. That's 155 degrees. All right, the reference angle is the angle formed by the terminal side and the x-axis. All right, so the 180 minus 155 is 25 degrees. So the reference angle would be 25 degrees. All right, for 250, what quadrant is 250 in? Well, 250 is in quadrant 3. Going from the x-axis, but this time I'm subtracting 180, so I'm doing 250 minus 180, which means my reference angle is 70 degrees. And then 359, that's quadrant 4, which means I am subtracting that angle from 360, and 360 minus 359 is 1 degree. So the reference angle is 1 degree from that quadrant 4. All right, now the good news is that, they gave you some exercises just to get you comfortable with finding the reference angle, but really all our reference angles are going to come down to our exact values from 30, 45, and 60. So the reference angles that we'll be using from here on out are going to be the 30, 45, and 60. Most of our reference angles will always go back to that. All right, so let's work some of these problems going through the 4 steps that we talked about earlier. All right, so if I'm looking for the exact value of the cosine of 150 degrees, the first thing I'm going to do, and I'm going to write out the steps, is determine what quadrant that's in. Well, 150 degrees is in quadrant 2. All right, then I'm going to find the reference angle. So I'm going to do 180 minus 150, which is 30 degrees, which means I'm looking for the exact value of the cosine of 30 degrees. All right, so we know the exact value of the cosine of 30 degrees is the square root of 3 over 2. Those values are coming from either the unit circle or the chart. All right, so you've got to know the 30, 45, 60. We know that the cosine of 30 degrees is the square root of 3 over 2. And the last thing I have to do is determine whether the sign is positive or negative. That goes back to my original angle. I'm in quadrant 2, and we know that cosine is negative in quadrant 2, which means my final answer here is negative square root 3 over 2. Okay, going on, the second one I'm going to do is the sine of 210 degrees. All right, so that is in quadrant 3. To find the reference angle, I do 210 minus 180, which is 30 degrees. So I'm looking for the exact value of the sine of 30 degrees. Well, the sine of 30 degrees is 1/2. And I have to determine, I should write that up here, is 1/2, and I have to determine whether this is positive or negative. Well, quadrant 3, what's positive in quadrant 3? That's tangent and cotangent, which means my answer is once again going to be negative. All right, let's do the tangent of 120 degrees. So at this point, you should be telling me what quadrant is 120 degrees in. Pause, yes, quadrant 2. To find the reference angle, subtract the angle from 180, and I get 60 degrees. So I'm looking for the tangent of 60 degrees, which we know from our chart. Hopefully you're learning your chart. This is the square root of 3. This is in quadrant 2, and tangent is only positive in quadrant 3 and 1. So quadrant 2 means I'm still dealing with negative. All my examples have been negative. That's okay. All right, so my answer is negative square root 3. And then the last one I'm going to work like this is the sine of 3 pi over 2. Now some of these are in radians and some of these are in degrees, and you might recognize this without converting it to degrees. But if you don't and you're more comfortable with degrees, go ahead and convert that. That's the sine of 270 degrees. And the reason I wanted to put this in here is because you have to know the exact values of the quadrantals as well. Remember, the quadrantals aren't in a quadrant. They lie on either the x or the y axis. So if I'm looking at this, I'm not going through those 4 steps because it's not in a quadrant. I have to recognize it's a quadrantal. So it's actually down here, right? It's the sine of 270 degrees. Well, if you remember the unit circle that I talked about, this point down here would be 0, -1, right? Which means my sine value, which is my y value, is -1. So the sine of 270 degrees, or 3 pi over 2, equals -1. All right, I'm going to keep working. So these are just example problems from what your homework looks like. It says to find the quadrant that theta lies in if given these conditions. All right, so this is just really a matter of deductive reasoning and practicing, recognizing whether your final answer is going to be positive or negative. So remember, all seniors take calculus. All sine and cosecant are positive in quadrant 2, tangent, cotangent are positive in quadrant 3, cosine and secant are positive in quadrant 4. All right, my conditions for this one are sine is negative. That eliminates quadrant 1. Because sine is less than 0, it eliminates quadrant 2. All right, so sine is negative, eliminates quadrant 1 and 2. Cosine being negative, or cosine is less than 0, eliminates quadrant 4 and 1, but we'd already eliminated 1, which means the only quadrant that this could possibly be is quadrant 3. All right, in the last example I'm going to do, it says find the values of the 6 trig functions if cotangent is -7/9 and theta is in quadrant 2. Now we've already done problems from 6 point, I don't know if it was 6.1, yeah, 6.1 were like this, but our theta was always in quadrant 1, so we didn't have to deal with the negative. We're not going to do anything different here. We just need to pay attention to what quadrant that's in, because that's going to determine whether our functions are positive or negative at the end. All right, so this is the information they've given me. They've given me that cotangent of theta is -7/9. So this is one that I would just say, hey, you know what? We better draw a right triangle so we can figure out what's going on here. Now notice I didn't draw it in quadrant 2 and label -7/9, blah, blah, blah. That doesn't matter. That negative is just meaning that's telling me what quadrant theta is in. It doesn't matter. You're not going to deal with the negatives until the end of it. So let's label our theta. We know that cotangent is the reciprocal of tangent. Tangent is opposite over adjacent. So cotangent is adjacent over opposite. So we've got 7/9, adjacent over opposite. I need to find my hypotenuse here. So I'm going to use the Pythagorean theorem, and I know that 7 squared plus 9 squared is going to equal my hypotenuse squared. So I've got 49 plus 81 equals c squared, or c squared is 130, which means C is the square root of 130. Now, don't need to worry about simplifying that radical. Just leave it as the square root of 130. All right, so let's find all 6 trig functions. We've got the sine of theta is opposite over hypotenuse. I'm in quadrant 2, so sine of theta is positive. All right, I've got cosine of theta is adjacent over the hypotenuse. I'm in quadrant 2 where cosine is negative, so that's going to be negative. And I've got the tangent of theta is the opposite over the adjacent, and we already know that's negative because it's a reciprocal of cotangent. That was given, but quadrant 2, tangent is negative in quadrant 2. And then our reciprocals, I'm just going to flip them. So we've got the square root of 130 over 9. We've got negative square root of 130 over 7. And then cotangent of theta, we've got negative 7 over 9. And like I said, don't worry about drawing your triangle in the second quadrant and labeling the negative. Just pay attention to what quadrant you're in and make sure your positive or negative signs are right at the end.